Hello everyone, and thanks for watching Edupedia World Videos. In this video, we discuss solutions to Part C, that is Mathematics, for the 2016 JEE Mains paper. We will be following the test booklet code E. We are given P is equal to limit x goes to 0 plus 1 plus tan square of root x to the power of 1 by 2x. So all we need to do is write this in the proper fashion. This can be written as x goes to 0 plus 1 plus tan square root x to the power of 1 by tan square root x, and we only do this so that we can use the limit 1 plus x to the power 1 by x. What is left with is tan square root x divided by 2x. And the first part is just simply e, because limit x goes to 0, 1 plus y to the power 1 by y is e. So what we get is, there's still another limit remaining, e to the power of tan square root x by 2 times. Now we can write this as root x whole square. And we know as x goes to 0, tan y by y is 1. So this term becomes 1, and what we are left with is e to the power 1 by 2. Which means that ln p is equal to 1 by 2, which means the answer is option 3. In 71, we are given f of x is equal to mod of ln2 minus sin x, and g of x is equal to f of x is equal to mod ln2 minus sin of mod ln2 minus sin x, right? And we need to find out whether it's differentiable or not. So first of all, when the limit we are taking is x is close to 0. So if x is a very small number, sin x is a very small number, right? So ln2 minus sin x is obviously a positive number. So for x greater than 0, we can write g of x is equal to mod of ln2 minus sin of ln2 minus x, because ln2 is obviously greater than x. Now what about sin of ln2 minus? For that we can look at the approximate values. ln2 is approximately 0.7. We need to find out what sin of 0.7 approximately, because if x is very small, this will be sin of ln2. We need to find out whether or not this is greater than or less than 0.7. There's one comparison which we can do easily. Pi is 3.14. So pi by 4 is slightly less than 0.8, something like 0.79 or 0.785, right? And we know sin of pi by 4 is 1 by root 2, which is root 2 by 2, which is 1.414 by 2, approximately 0.7, right? So we know that sin of pi by 4, sin of 0.79 is approximately 0.7. So sin of something smaller than that, sin of 0.7 will obviously be less than 0.7, because sin x is an increasing function. If you take a value slightly smaller than 45, it will give you a value slightly smaller than 0.7, right? So this modulus will also be, the thing inside the modulus will again be positive. So you get g of x is equal to ln2 minus sin of ln2 minus sin x for x greater than 0. What about for x less than 0? If x is less than 0 but approaching 0, sin x is negative, but it's still a very small number. ln2 minus sin x is still positive, and ln2 minus sin of that is still again positive, because everything else is the same, just this modulus is shifted by a slight amount, right? So g of x for x less than 0 but approaching 0 is the same ln2 minus sin of ln2 minus sin x. So we can see that the function now is differentiable, because even after removing all the moduluses, they both have the same structure. And now we can just calculate the value. G dash of x is equal to minus cos of ln2 minus sin x multiplied by minus cos x. So minus and minus cancel. What we get is cos x cos of ln2 minus sin x. And for x is equal to 0, cos x is 1, we simply get cos of ln2 because sin x is 0. So the answer to this question will be g dash 0 is cos of ln2, which means the answer is option 2. This completes the solutions. Thank you.